My name is Jessie Taylor. Today I am here to speak to you about the paper, Declines of Freshwater Turtles Associated with the Climatic Drying of the Australia's Murray-Darling Basin. The paper concentrates on the effects of climate change on Shelodina longicollis, Emydura macquarieae and Shelodina expansa. A short time ago, the Murray-Darling Basin suffered the most severe drought in recent history, occurring from 2001 to 2010. For freshwater species, such as the ones mentioned before, changes, especially declines in the flows of rivers, can cause additional threats that have the ability to cause compound non-climatic pressures. As a result of this drought-severe drying, acidification and salinisation occurred. It has been established in the 21st century that the changing anthropogenic climate, including impacts on temperature-based gender determination and increase on drought severity, are credible threats. In this report, Bruce Chessman concludes upon the changes that have occurred in the turtle populations during a 35-year period. The study area used included the Murray River and the floodplain located downstream from the Yarrawonga Weir. Turtles were sampled between December 1976 and December 1982, then again from December 2009 to March 2011. The original period of sampling occurred following a significant rainfall and flood event, whilst the second samples were taken at the completion of the Millennium Flood and throughout the recovery of the water body. Trapping was conducted in late spring, summer and early autumn, as this is when the species was most active. The main method used for trapping were hoop nets, of which were baited with dog food and then wrapped in mosquito wire. Traps were secured using semi-submerged logs as well as the shoreline to ensure that all traps reached the bottom of the water body. Traps were checked every 2.2 hours so that the species that were caught could be removed and the traps then reset. 11 sessions of trapping were undertaken in the original period, and then 19 sessions completed with 1,968 hours in the second period. Other trapping techniques used included dip nets, hand capture and a CN net. Each of the nets used was a stretch mesh size of 13 mm. All turtles captured were identified and then measured by a straight line medial carapace using expanding and vernier calipers. Gender of the species was determined with an external examination. Data was then assessed using several methods and by comparing the data collected from each of the two testing periods. Changes in abundance were established by the differing capture rates, that is, number of turtles per hour of trapping. Following the completion of the sampling, data was then evaluated and compared for the two different periods. The hoop nets used catered for 72% of the catch rate in the first period, whilst in 09 to 11 these nets catered for 89% of the catch. Catch rates for C. longicollis for the 09 to 11 period are only 9% of those of the original period. However, in macquarieae in the 09 to 11 period was 31% of those caught in the previous period. Figure 1 in the PowerPoint shows the catch rates for each of the species from hoop nets. The circles in the graph show the mean catch rates. It was determined that the total number of turtles captured in the 09 to 11 period was approximately half of those caught during the 1976 to 82 period, despite increasing sampling times. Figure 2 shows the proportion of each of the species caught at the different types of water bodies. It can then be concluded for C. longicollis that there was 91% decline in species. For E. macquarieae there was a 69% decrease in the number of species caught. However, no significant difference was concluded for C. expansa. It is clear that these results that the drought period within the Murray-Darling Basin has had a significant and varying influence on species. It was concluded that the declines for C. longicollis were due to populations, due to drought-induced loss of their habitat. E. macquarieae's decline was believed to be of similar consequences, as well as increased predation. However, for C. expansa there was no significant decline. Chessman then concludes that such findings can confirm that different species react differently to climatic events such as drought. Ecology of such animals is therefore required so that individual species reactions can be comprehensively understood and interpreted, so that as to be able to acknowledge animals that are more vulnerable to such events.